off of this, because we haven't actually made any samples yet. We've just been doing background and actually looking at the well-simmered metal spinels that Wei presented. He found that the magnesium vanadium oxide spinel lattice matches very well to the MgO. So that's something we can try to grow once the MBE is back up. So this is sort of, I haven't looked into this thoroughly yet, but it's just sort of a thought is instead of doing the tungsten-free tantalum, since we're not going to compete with Parkin's group, is to actually go in and look at these spinels, since we have a seed layer in mind, and there shouldn't be much forefront. Do you think that's a...
So this is insulator, right?
Yes, this is an insulator.
Is this for spin Hall angle?
The insulator is...
How do you pass current?
Yeah, again, I haven't looked into it through. I just had the one conversation with Wei, so I'm planning on. I'm planning on looking into this more in sort of next week, and I'll present what I learned about the tungsten-free tantalum project, because the actual material growth for that is very sort of non-standard. I think there's some good learning there.
Oh, you read the abstract or?
No. The work I was doing before I realized that Parkin's group was just going to beat us to actually grow, because you can't just lattice match that material. It's not a standard growth. Okay. I think that'd be useful to share since I did all that work anyhow.
So what's the spin angle they claimed?
0.45.
Not that large, right?
Not that, and that's sort of what was predicted in the theory anyhow. It was going from 0.3 to 0.45. I think the other paper was 0.47. So it was, a 50% increase-ish of the spinel angle of tungsten was what they were going for. And then sort of the hold open project.
Sorry. Is that the Stewart Parking ambient?
Max Planck.
It's a different Stewart.
No, same. He moved. He moved 2 years ago.
Yeah.
2 years?
You didn't know. He married a German woman.
Yeah, so the groups are him and his wife. So it's like this gigantic group of cross-pollination. They're doing a lot of experiments. And there's no way we can keep up with them right now.
Experiments.
He worked to grow 120%.
120. 120.
Yeah.
It's gigantic.
So collaborator has more than 60% work with her. I think also part also maybe bigger.
His finding is a huge loss to IBM, right?
So with
yes or no? Yeah.
So it's a professional marriage or like personal marriage?
Good question. It seems it's a personal marriage. It's a real marriage.
Oh wow!
He's very happy. It seems he's very happy. Anytime you see, he's at the seminar or session, he's very happy. Yeah, that's good. Good for him. He was not very happy before. Now he's happy. Happy married.
So with the hold open project, if you remember, Pro told you we had some issues with the iron deposition, which I'm going to go into a little more detail. But I made some cobalt iron boron samples in the meantime before we get the system down, which Pro is currently patterning. But all of these curves I'm going to show from the VSM are of what I thought was iron, and you can see I'm suggesting films of like 0.5 or this bottom one is when I figured out there's no iron there. So I thought the film was 0.03 nanometers based on the VSM, and that was with my sample. So there's clearly nothing there. But most of my other ones, I was getting film thicknesses, which calculated out to be like 0.05, 0.07. So the noise was just so bad I couldn't tell there was no iron there. You can see some of these. The film suggests 1 nanometer, which is what I was sputtering 3.
This is using OLV?
This is using the MBE when the iron wasn't working. But the VSM was so bad that I thought I had 1 nanometer films. So that's sort of, it was really confusing.
It's our VSM, right?
Our VSM.
Right? Yeah.